All right, working on our domain and range for today. So again, just to review, we talked about domain in our day one. So just reviewing what that actually means. Um, Sorry, just checking to make sure it was working. So looking at what domain means, again, we did talk about this with day one. So domain are your input values. We also refer to them a lot as your X values. But we're also going to pull back from our linears a little bit more. This is our independent variable. Those are your domains. So now we do refer to them as our X values, but they use a lot of different letters. N is another very common letter that they like to use for that. So focusing more on the fact that it's your input values. It's what you use to plug into the equation or you use from the table to be able to figure out your other answer, which is why it's also your independent variable. It's the one that figures out the other number. So our range are the output values, y values, or your dependent variable. Those are the range. So those are kind of the answers that we get. So again, if we have an equation we're using, it's our answers that we get once we plug in those domain values. So then a couple of new words for us today are the terms continuous and discontinuous. We're going to be looking a lot at graphs both today and the next several days as we go through this unit. So the term continuous means that the graph is connected from start to finish. So there's no, as I like to call them, jumps or breaks in the graph. So I tell students a lot as we're drawing them, your continuous graphs, you could draw that graph without picking your pencil up at all. So like our lines that we've been doing, so our linears that we've been doing, that would be a continuous graph because you could draw that whole line without once having to pick your pencil up off of the paper. So those are our continuous graphs. So our discontinuous graphs are graphs that are not connected from start to finish. Start to finish. It has jumps or breaks. So like if you were just plotting 5 points, that would be discontinuous because you would just have 5 random dots around your graph. That would be a discontinuous graph. We're going to go through a couple of graphs in this unit called step graphs and piecewise graphs. Those are discontinuous because they're not going to be completely connected from start to finish. So then the other thing we're going to take a look at is some different ways to state our domain and range. So one of them is our roster form. We've done a little bit with roster form to begin with. So what you're doing is you're making a list. You're making a list of the numbers for our roster form there. As I said, we did it a little bit within the day one notes. We made lists of our domains and ranges. So we'll see an example of that down below. We have our set builder notation. So this is another way of being able to show numbers that are included within an answer, which is known as your solution set. we're going to be using a lot of inequalities. So that would be our less than, greater than, less than or equal to, greater than or equal to signs. We're going to kind of be bringing those back a little bit as well. And then our last one is our interval notation. Our interval notation, again, is just a different way of being able to show your values, which use parentheses and brackets depending on if a value is included or not included within the set. So let's take a look at some examples down here. So roster form is used, for example, if you have a set of points. So let's say I have the points 0, 1, 1, 2, 2, 3. So we could list our domain using roster form. And we would want to use roster form.
At this time, it is now first lunch. Staff, please remember you are to accompany your class to the cafeteria. Once again, it is now time for first lunch. And staff, you are to accompany your class to the cafeteria. Thank you.
Excuse me for that. So roster form is used when you need to make a list. Now we're making a list because your domain is only these points. I'm sorry, only these values. These values. It's no decimals. There's no fractions that are included. It's purely 0, 1, and 2. There's nothing else being used there. And then we always order least to greatest, which again, we did talk about that a little bit in our day 1. So set builder. So here's an example of set builder notation being used. So this would read as X such that X is an element of the reals. So this bar rate here, that is such that, okay? So it's X such that X is an element of the reals. And again, the reals just means all numbers that we've learned so far. So that means it could be anything. Could be anything. Could be a fraction, could be a decimal, could be an integer, could be negative, could be positive, doesn't matter. So again, right here, which means it could be anything. So then looking down here, here's an example for a range. So this would be y such that y is greater than or equal to 0. So this is what I mean by we would use inequalities here. So we're using the inequality to show that our range is greater than or equal to 0, meaning it can be any positive value. So your range has a lot of numbers that it uses, only can be positives or 0. So then for our interval notation, parentheses means that a number is not included. Brackets means that it is included. And then for your infinity signs, you always use a parentheses with it because infinity continues on forever. So we don't put a bracket because you can't put a stopping point on that. So a couple of examples. Let's say we have that X has to be greater than 5. If I were to look at this on a number line, here's my 5. It would be an open circle shaded to the right. So our interval notation always goes from the left of the number line all the way to the right. So the first thing I would hit here is that 5. So it's going to be a parenthesis because 5 is not included, which is why it's got the open circle. And then this is going to go up to positive infinity. So X being greater than 5 is going to be parenthesis 5 comma infinity. Let's say I have X is less than or equal to negative 4. Again, looking on the number line, I'd have a closed circle on negative 4, but it's going to be shaded to the left because it's less than. So if I'm coming from the left, first thing I would see shaded wise is that arrow. So that's going to be negative infinity. I'm coming from the left. I'm coming from negative infinity. I stop at negative 4, which would have a bracket because that's a closed circle. So we will play around with all these as we're going through. So let's first talk about some examples of domain. which again is our input values that don't really involve any algebra to it. It's just kind of thinking through the problem here a little bit. So first one, we have a store sells self-serve frozen yogurt sundaes. The function C of W represents the cost in dollars of a sundae weighing W ounces. An appropriate domain for this function would be. So again, W is representing the weight, W ounces, representing the weight. If I look here, this is in the domain spot. W is our domain. So we're looking for a reasonable domain. So if we're thinking here about the weight of something, you can have decimals. You can have fractions. You can have something weigh 2.3 ounces. That is allowed here. What's not allowed here is it can't be negative. You cannot have a negative weight. Can't be negative. So let's look at our options here. Integers include negative numbers. So we're going to cross those out. Rationals also include negative numbers. Okay. So choice 1 and 2 are automatically out. So 3 integers, non-negative integers would be 1, 2, 3, so on and so forth. But that doesn't include our decimals. We can have decimals. So that's why we want our rationals, because your rationals include decimals and your rationals include fractions as well. So it's going to be that one, but it has to be positive. All right, taking a look at our next one here. The daily cost of production in a factory is calculated, sorry, my grammar's terrible with that, using this equation here, where X is the number of complete products manufactured. Which set of numbers best defines the domain of C of X? So again, X is the number of complete products that have been manufactured. So it can't be a decimal because it's got to be completed. And it can't be negative. It can't make negative number of products. So it's not going to be integers. Real numbers includes fractions and decimals. Rationals include fractions and decimals. So it's going to be our whole numbers. Because again, you can't complete, if you complete the product, you got a whole one there. Okay, so we can't have decimals or fractions. 3, a grocery store sells packages of beefs. The function C of W represents the cost in dollars of a package of beef weighing W pounds. So again, our domain is a weight here. The most appropriate domain. So again, it's not going to be anything negative. So choice 1 and 2 are out of the running. But it being a weight, it can have decimals and fractions. So it's going to be any positive rational number. And then the dolphin jumps out of the water and then back into the water. His jump would be graphed using a set of axes where X is time and represents time, and Y represents distance above or below sea level. The domain of this graph is represented by. So again, time. Time can't be negative. So automatically integers are gone. Real numbers are gone because it can't be negative. So with the time though, can we have a fraction of time? Like could he go for 0.5 seconds or could they jump for 1.75 seconds? Absolutely. So it's not just going to be integers. It's going to be the positive real numbers because it could be fractions and all that stuff. All right, so let's switch our thinking a little bit. So we're going to move now on to our discontinuous graphs, and then we're going to take a look at some continuous graphs. And we will practice our different notations. So when stating the domain and range from discontinuous graphs, you need to make a list of the values. This is also known as roster form. All right, so let's take a look at our discontinuous graphs here. So one example of a discontinuous graph would be your ordered pairs. So we've practiced this a little bit last time. So our ordered pairs, again, domain would be your x's. So if I'm looking at all my x's, I need to go in order from least to greatest. So -2, -1, 0, and 3. Okay, then my range here, looking at my y's, I got 3, 4, -5, 7. So -5 has to go first. 3, 4, and 7. Domains are our x's, ranges are the y values. So for our table, domain is the x's, so domain is this side. My 1 is repeated, but when I write that domain, I don't repeat the 1. I just write the 1 twice. So my domain would just simply be 1, 3, 9. Even though I have a repeat value of 1, I don't repeat it when I list out my domain. My range would be 1, 9, 36, and 81. Mapping diagram. This is new for us. Where the arrow starts from, that is our domain. Where the arrow ends, that is our range. So our first little bubble here is our domain. Second little bubble is our range. So our domain would be 2, 4, 6. Our range would be 8, 10, and 12. Now this one, each domain has only one arrow coming from it. So that means they're each used once. This would be a function in mapping diagrams. Because again, each domain has only one arrow coming off of it. So looking at a graph, these are just the graph of points. So what we have to look at is where they are all on the x. So this is -1, 0, 1, 2, 3, 4. If I'm looking along my x-axis. So I'm going to list -1, 0, 1, 2, 3, and 4. Our range, 1, 2, 3, 4, 5. So this is down at -5. 1, 2, 3, -3, -1, 1, 3, and 5. That is where all of my points are on the y values. So just discontinuous, you list them out using roster form. You just write all of the numbers that are being used because it's not a range. It's not using anything in between those numbers. All right, taking a look at our last page here, our continuous ones. So I am going to start, actually here on the right, I'm going to take a look at my continuous graphs first. So for continuous graphs, you can use either set builder or interval notation. So I'm actually going to end up using both just to show you what they would look like using both of those notations. So I'm going to do set builder first. Okay. So for this one, my domain starts at -1, -2, -3, -4, -5, and it goes to 1, 2, +3. So my domain in set builder would be x such that we always start with that. So it goes from -5 is less than or equal to x is less than or equal to 3. Okay. I'm going to use blue for my interval. So an interval notation, because -5 and 3 are included, because they are closed circles, you would do bracket -5 to +3, close bracket. All right. My range, here's my lowest, that's at 1, 2, 3, 4, -5. My highest at 1, 2, 3. My highest is up here at 4. So in set builder, that would be y such that -5 is less than or equal to y is less than or equal to 4. But in interval, that would be -5 to 4. So I kind of like interval. I find it's a little quicker than my set builder, but that is what they would both look like, and they mean the same thing. Okay. So let's try for my V-shaped graph over here. Again, I'm going to do both. I'm going to do set builder and interval so that you can see them. So my graph here, that has arrows going on forever. So I kind of have to ask myself, because of this arrows, this actually keeps going on forever. It will use every x value possible. So the way we write that is we say x such that x is an element. So this is like a funky E. So I kind of make a C and then put a line through it. X is an element of the reals, which is 2 lines, and then you make a capital R over it. An interval, when it can be any number, it's negative infinity to positive infinity. Now my range values here, my lowest is 0. My lowest y value here is 0, and it's up. And again, it's got arrows, so it's going to keep going up forever and ever and ever. So y such that y is greater than or equal to 0. An interval, that would be 0 to infinity and beyond, just like Buzz Lightyear. All right, take a look at our last one here. Again, we got arrow on the left side, that's going to keep going forever. Arrow on the right side, that's going to keep going forever. So our domain would be x such that x is an element of the reals. XER. Interval notation wise, that would be negative infinity to positive infinity. For my y's, again, this is going to keep going forever up. This is going to keep going forever down. So this is also going to be an element of the reals. This is going to use every y value imaginable. So y is an element of the reals. So this would also be negative infinity to positive infinity. So those are my continuous graphs. Equations for our continuous graphs. I type it in my calculator and I look at the graph of it, is honestly what I do. So this first one, y is equal to 3x minus 5, would be a graph that looks like that. Again, put it in your calculator, look at your graph. I'm going to keep my domain and range going the way I was doing it. This graph is much like this graph down here that we just did, that last one down there on the right side. It can be anything. So x such that x is an element of the reals. Interval notation wise, negative infinity to positive infinity. Range, again, is going to be anything. That's going to keep going forever up and down. So y is also an element of the reals. So y such that y is an element of the reals is our set builder notation. Interval notation, negative infinity to positive infinity. And then our last one here, when we type this in the calculator to look at our graph, we get a nice little parabola shape here. Domain, again, those arrows are going to keep going forever and ever and ever. It will eventually use every x value it possibly can. So x is an element of the reals, or negative infinity to positive infinity if you are using interval notation. Our y's, however, are not going to use every possible y value because it does not go below our minimum right here. This is our lowest. There's nothing lower than that. That's where y is a 3. So it can be 3 or it can be anything higher than 3. So y such that y is greater than or equal to 3. Interval notation, it would be bracket 3 to infinity with a parentheses. So we'll keep practicing that. We'll talk about it every single day going forward.